So thanks a lot for inviting me. And as it was announced, today I want to talk about inequality and the zero lower bound. And let me point out that this is joint work with Joel Marbet at CENFI, Galo Nuño at the Bank of Spain, and Omar Rachedi at the SADE Business School. The motivation for our investigation is straightforward. We go to the data and we see a secular decline in global real rates over the last 30 years. This decline in real rates was made acuter by the 2007 and 2008 financial crisis and the COVID-19 shock. And as a result, the zero lower bound on the nominal interest rates has become a pervasive feature of advanced economies. I imagine that in Japan, this is much more obvious than in other countries. And our guess is that this is most likely to return, or the situation is going to return once the current inflationary pressures abate. So if you ask for my forecast, I think that the probability that advanced economies will be at the zero lower bound around 2030 is quite high. There has been many great papers written about the zero lower bound, but most of them had been within the context of representative agent models. The classic works, for instance, of Egerton and Woodford, or Cristiano, Eichenbaum, and Rebello, and my own work on the nonlinear properties of economies at the zero lower bound. In this paper, we want to push the idea a little bit further and argue that the effects of the zero lower bound on both the aggregate behavior of the economy and the stance of monetary policy also depend on household inequality. So why is it so? To answer this question, we are going to build a heterogeneous agent neo-Keynesian model, so-called HANK these days, with two interesting properties. We are going to have aggregate shocks, and we are going to have the zero lower bound. Of course, solving these HANK models with full dynamics and the zero lower bound is going to be a challenge in itself, and we are going to apply to do so a new methodology that I developed with Samuel Hurtado and Galo Nuño that is built around the idea of employing neural networks to approximate the aggregate loss of motion of the economy despite the presence of heterogeneity. And what we are going to show is the presence of three channels that alter the room for maneuver of the central bank by reducing the level of the interest rates. The first one is the so-called deflationary bias, which is operative also in representative agent models and was identified already around 2007 by Billy and Adams. And the idea is very simple. Since agents expect that inflation cannot be stabilized at the zero lower bound, that basically makes the economy operate on average at a lower rate of capacity that will happen otherwise, and then nominal rates decrease even out of the zero lower bound because of this expectation of operating at a lower capacity on average. What is interesting are channels number 2 and number 3 because they come directly from the presence of inequality. The first is the presence of precautionary savings because agents, households are going to have idiosyncratic shocks to their labor earnings. They are going to try to self-insure. And because they are going to try to self-insure, that's going to increase the demand for assets in the economy, which is going to lower their rate of return. And this is very similar, if you recall, to the idea in Ayagari, that the presence of wealth heterogeneity is going to lower rates on average. And we are going to have a third channel that is also linked with precautionary savings, but now is with aggregate risk. So households, agents are not only worried about their own idiosyncratic shocks, but they are also worried about the aggregate risk. And the aggregate risk is particularly serious when we have a zero lower bound, because the fact that the limits of monetary policy are tighter than otherwise, recessions are relatively larger, and they weigh more on wealth-poor households. And hence, these wealth-poor households try to insure themselves by accumulating more assets as much as they can, and that by increasing the demand for assets, lower the interest rate. Okay, so the presence of wealth heterogeneity leads to precautionary savings, both because of idiosyncratic risk and aggregate risk. And that means that in this setting, monetary policy is non-neutral, even in the long run. A reduction in the inflation target leads to a drop in the real interest rate. And why is that the case? Because with a lower inflation target, we are going to hit the zero lower bound more often, and then the precautionary behavior motive that I highlighted before is going to be more salient. In that sense, the central bank has an effect on the real rate of return, even in the long run. How big is this effect? Well, we calibrate the model, and after computing, we find that changes in the trend inflation or the target set by the central banks and changes in household inequality account for at least 21% of the drop in real rates over the recent decades. Now, how big is this 21%? It's going to be around 46 basis points out of the 150 basis points that we have observed of reduction in real rates since the late 1980s. So this is an important channel. I want to highlight nonetheless that this is not the only channel. There are many other reasons why the real rates may have dropped, and I have, for instance, very recently published a paper on the shortage of safe assets in the world economy. So I'm not claiming that changes in the trend inflation and households inequality explain all the drop in real rates. We are just claiming that they explain an important part of the drop in real rates. So let me go without further ado to enter into the description of the model. We are going to have a discrete time, infinite horizon, sticky price economy, and we are going to have heterogeneous households. So basically, we are going to have a continuum of ex-ante identical households that face idiosyncratic productivity shocks, and that leads to exposed heterogeneity. The households are going to choose consumption, bond holdings, and labor supply, but these bond holdings are going to be limited by a borrowing constraint. We are going to have firms in a very standard neo-Keynesian setup where there is a final good producer, there is a perfectly competitor that aggregates the intermediate goods. We are going to have intermediate good producers that have market power, but they are subject to a nominal rigidity. And today we are going to do a Rothenberg price adjustment cost, makes our life a little bit easier and gets everything that we want to discuss. In terms of aggregate shocks, the easiest thing to do to keep the model relatively parsimonious is to have a preference shock. And you can think about it as, let's say, a stand-in for financial friction shocks, fiscal policy, and many other possibilities. And in that sense, we follow the pioneering work of Cristiano, Eichenbaum, and Rebello. So how do households work? Well, they want to maximize the expected discounted utility, subject to this preference shock that is going to follow an AR1 process. The instantaneous utility function is very straightforward, very conventional. And what we have is that households can use their income to consume or to accumulate bonds subject to some borrowing constraint B under HAT. And in terms of income, they are going to have some wage income. And you can see over here the S, which is the idiosyncratic productivity shock. And you have two parameters, tau and 1 minus gamma, because we are going to have a progressive income tax. So those are the two parameters that are going to index the progressivity of the income tax. And they are going to get the rate of return on their bonds. R is the nominal rate, pi is the inflation. And they are also going to get the share of firm profits in the economy that are redistributed according to households' idiosyncratic productivity. And basically what we want to capture in that way is that high productivity households are also likely to be the households that own more of the stock of capital in the economy. In terms of firms, we have a final good producer that assembles intermediate goods using a CX production function. And each of the intermediate goods is produced by a constant returns to scale technology, just using labor. To make things simple today, we are dropping physical capital, although it will be very easy to add it. The intermediate good producers are going to choose a sequence of prices to maximize their expected discounted profits, given that they are subject to some Rothenberg adjustment cost. And the reason we pick Rothenberg instead of Calvo or Taylor is just because in that way we don't need to keep track of the heterogeneity of firms, which is not really at the core of what we want to say today. The point in our paper is the heterogeneity of the households. And solving this problem yields the well-known Neo-Keynesian Phillips curve. That depends, of course, on expected inflation and the marginal cost in the economy. This is well known, so let me not spend much time on it. In terms of a monetary authority, we have a central bank that follows a Taylor rule, but that is subject to the zero lower constraint. In particular, the nominal interest rate, and here note that I'm writing everything in gross terms, is the max of 1, so that's the zero lower bound. The net cannot go below 0. If you wanted to give room in the model to have a little bit of negative rates, we could put over here 0.99 or maybe 0.98 even, but there is still a lower bound nonetheless. And then there is some steady state nominal interest rate, and there is going to be some response to inflation in deviations with respect to a target, and output in deviations with respect to some steady state, given some response parameters. And the fiscal authority is going to raise progressively income taxes to finance a fixed amount of outstanding debt. Why do we have a fiscal authority? Well, first of all, because we want to have the concept of debt, government debt within the model, which is the asset in which the households are going to save and do self-insurance. But second, because in that way we can do a lot of exercises later on, thinking about how fiscal and monetary policy can interact with each other by changing the degree of inequality in the economy. The calibration of the model is going to be relatively straightforward. We are going to have an inflation target of 2% annualized. We are going to have a volatility of the demand shock that is going to reproduce that the economy hits the zero lower bound with a 10%, which is the standard number after Coibion and his co-authors. Of course, you could argue that in my motivation, I was saying that the advanced economies are hitting the zero lower bound more often than this 10%. And well, in that case, the more you hit the zero lower bound, the better it's going to be for all the arguments are going to make, the stronger are going to be the results. So in that sense, this 10% frequency is a best case scenario or a worst case scenario for me, a conservative stand. The idiosyncratic risk is calibrated to match that there is a 30% of borrowers like Kaplan, Violante, and Weidner, and that there is a 10% average marginal propensity to consume, as many people in the consumption literature have documented. The aggregate liquid wealth, which is roughly equivalent to the net government debt. So this is not the outstanding government debt. This is the government debt once you have subtracted assets by the government, is the net position, equals around 25% to annual GDP, which people have argued is not a bad number for the US. And we have tax progressivity and Rothenberg cost adjustment that corresponds to the microdata in the US. So I would argue that this is a very, very standard calibration. Something that is novel in this paper is how we compute the solution. Some of you may have some experience with Hank models, and you probably know that dealing with Hank models is not easy, in particular because it's difficult to keep track of the distribution of agents changing over time. And what we propose is a very, I think, efficient strategy based on work I have done with Hurtado and Nuño. And the idea is that the agents, instead of keeping track of the whole distribution of agents, only keep track of some moments of the distribution. And this was proposed, of course, by Krusell and Smith in 1998 as a bounded rationality solution. What is interesting is that instead of trying to estimate log linear loss of motion, we are going to use neural networks to determine the fully nonlinear loss of motion. In that way, our agents are going to predict inflation and a term related to inflation expectations that shows up in the New Keynesian-Phillips curve using these neural networks. And in that way, we are going to be able to keep track of the nonlinear implications that the zero lower bound has on the aggregate loss of motion, and that I have demonstrated are key already in a representative agent model in my paper in 2015. In particular, what we are going to do is that the agents are going to have a perceived law of motion for how inflation evolves over time. We are going to simulate the economy given that perceived law of motion, and then we use that simulation of the economy to train the neural network. And we will keep doing this until convergence. And it's very straightforward to show that there is going to be very, very strong nonlinearities. So what we do in this graph, you can see two panels, and you are going to see a blue line, which is the forecast errors of the neural network, and a red line, which are the forecast errors of using a Krusell-Smith type of approach. And you can see that our neural network does much, much better, not only in all simulated periods, but more importantly, in periods where there is a binding zero lower bound. So if you are trying to use a Krusell-Smith naive approach, you are not going to capture very well how inflation is evolving. That means you are not capturing the nonlinearities associated with the zero lower bound. But if you are using our neural network approach, you are doing really, really well. Look, our R square is 99.22%. So we are doing close to perfectly well. Okay, so that means that we are able to compute a hunk with a zero lower bound and aggregate shocks. That's very nice. That's in itself, I think, methodologically a very nice contribution. But what gets us really excited about this paper is that we also have something interesting to say about the economics of the problem. And in particular, what we can do is to compute first the ergodic distribution of variables in the model. By ergodic distribution, I mean I just keep simulating the model for many, many periods, and I can compute, and again, we are going to have different panels, and in blue, we are going to have ZLV hunk, which is the hunk model with a zero lower bound, and in red, we are going to have the ergodic distribution with hunk, but without the zero lower bound. In an economy, in a counterfactual economy where the central bank could lower interest rates below zero. And what you can see is that the economy with the zero lower bound is moved to the left. So on average, inflation is going to be lower. The nominal interest rate here is very clear that it gets stuck at zero, while over here it could go negative. Also, the real rate is a little bit moved to the left, and the aggregate consumption is also moved to the left. Okay, so what is going on over here? Well, to understand these ergodic distributions, we can look at the aggregate impulse response functions. And again, we are going to have impulse response functions to the economy with the zero lower bound and without the zero lower bound. These impulse response functions are nonlinear, so it's very interesting to look at what happens when we have a 1 standard deviation shock and a 3 standard deviation shock. And of course, these are negative shocks. Okay, so let's look at the panel at the bottom right. We see that the preference shock is the same with and without the zero lower bound. What happens when the shock is a 1 standard deviation shock? Well, the hunk with zero lower bound and the hunk without the zero lower bound respond pretty much the same in terms of inflation, nominal interest rates, output, and the real rate. Well, because the zero lower bound is not operative, so the economy is roughly the same. But when we have a large shock, the response now is very different. Look, for instance, what happens with the nominal rate. the nominal rate gets stuck over here in the economy with the zero lower bound because it cannot go below zero. However, in the economy without the zero lower bound, it can go below zero. What is the consequence of the economy not being able to reduce the nominal interest rate? That, of course, inflation goes down much more. There is the famous spiral of inflation at the zero lower bound, downward spiral. Output also goes much more down, and wages go much more down. Okay, and that's basically because we have one key price in the economy, the nominal rate, that cannot clear the market properly. So this skewing of the dynamics of the model to the left relative to a standard hunk is what is going to be driving these effects of precautionary saving that I was highlighting before. In particular, because think about here, look for instance at the wages. Wages go much more down when you take account of the zero lower bound that you don't take account of the zero lower bound, and this is going to have an effect on the household income. So what I'm doing over here is showing how the household income is going down with respect to the economy with hunk. There's the difference, excuse me, of the zero lower bound with hunk with respect to the economy with hunk. And what we see is that in the aggregate, total income goes down much more because wages go down much more. Profits go up a little bit because, of course, the fact that wages go down so much and firms have this Rottenberg adjustment cost means that they end up having a little bit of a better margin. And there is some, extra income because the interest rate doesn't go down, but this is very, very small. What is interesting is that when you actually look at households in the 10th percentile of the wealth distribution, on the 99th percentile of the wealth distribution, we see a very different behavior. Why is that? Because yes, both households lose roughly the same in terms of wages. After all, they have the same wage, and whether or not you are poor or rich does not depend on your labor idiosyncratic shock today, depends on your past histories of labor productivity shocks. But the households that are rich compensate part of this decrease in their income with their interest rates, which are higher than they will be in an economy without the zero lower bound. So the economy with the zero lower bound is being particularly bad for poor households. And we can see exactly the same if we look at their consumption. The zero lower bound is being particularly damaging for households in the 10th percentile of the wealth distribution, much less than for households in the 99th percentile. And not only we have distributional effects of a recessionary shock that are not present in standard models, but what we have also is that agents are going to anticipate these effects with respect to the future. And that's what it's going to take off to, and that's going to have an effect on what I was mentioning before, the precautionary behavior. And how can we tell that? Well, we can do it by comparing what a couple of concepts that I use a lot in my papers. So let me introduce the idea of the deterministic steady state. The deterministic steady state is a situation where the economy has settled down to its long-run behavior, where the agents ignore aggregate risk, which basically means that we are taking the aggregate risk to zero, the volatility of the aggregate risk to zero. And then we have the stochastic steady state, which is a situation where, again, the economy has settled down to some long-run behavior, where the agents take into account that is aggregate risk, but it just happens to be the case that no shock arrives along the equilibrium path. Okay? So deterministic steady state is a very natural concept. It's just an economy without aggregate shocks. The stochastic steady state is kind of an interesting situation because it's the economy with aggregate shocks, they just not happening along the equilibrium path. Why do we care about the stochastic steady state? Because it's going to tell us about the ergodic distribution of the economy. Of course, the economy is going to get shocks, but they are going to, the ergodic distribution of the economy is going to accumulate around the stochastic steady state. So think about the stochastic steady state as a construction that helps us to think about the ergodic behavior of the economy when it has these aggregate shocks. The agents take account of their own idiosyncratic labor shocks in both cases. And we can look, for instance, at comparisons between the deterministic steady state and the stochastic steady state in an economy that is a hunk with a zero lower bound, in a standard hunk economy, and in what we are going to call a rank. Rank is for representative agent neo-Keynesian with a zero lower bound. So let's look here at inflation. So at the deterministic steady state, inflation is 2% in all the three economies. Well, why? Because that's the target of the central bank. And there is no shocks, there is no aggregate shocks, so the central bank can deliver that target without any problem. But let's look now at what happens with the stochastic steady state. In the hunk model, the stochastic steady state, that is the long-run behavior of the economy, accumulates, in fact, around the 2%. That is the target, 1.99, a very small deviation. However, as soon as we have the zero lower bound, the stochastic steady state is only 1.91%. So we have this difference between these inflation targets and the realization of inflation along the stochastic steady state that comes from the presence of the zero lower bound. And we can see the same in the nominal rate. Over here, the target is 3%. The realization in the long run is 2.96%, but when you take account of the zero lower bound, you are actually at 2.8, and the real rate goes from 0.97 to 0.89. And that's why even a 10% frequency of the zero lower bound gives you this reduction of the real rate. Now, remember what I told you before. If you tell me, hey, the zero lower bound hits with much more frequency than this 10%, what is going to happen is that all these numbers are going to be even clearer. So this, instead of going from 0.97 to 0.89, will go to 0.8 or to 0.7. So in that sense, you can think about this as a conservative lower bound on the effect of the zero lower bound. And as I was mentioning before, this can be decomposed between the deflationary bias. And the deflationary bias, remember, is just because the economy is going to operate on average at a lower rate, at a lower level of output that you will have in the model without the zero lower bound, and that basically lowers the rate of return on the assets. Is going to be 8 percentage points. And remember, I already told you this also exists in the model with representative agent. And then we have 22 basis points that come from the idiosyncratic risk. Households want to self-insure against their own shocks, and 3 basis points come from the aggregate risk. Okay, and that's a little bit the composition that we have over there. I already kind of provide you with the intuition of what is going on with respect to the idiosyncratic risk. It's just Ayagari 1994 all over again. People want to self-insure against idiosyncratic risk, but this is different from the very basic result of Ayagari in the sense that is tying down directly this reduction in the real rate with the room of maneuver for the central bank, which I think people had not really highlighted before. And the precautionary saving due to the aggregate risk also is a new channel that people have not explored in a lot of detail. Let me skip the role of the inflation target, but basically what we try to argue in the paper is that how important this mechanism is depends on the target. When the target of inflation is very, very low, we are going to hit the zero lower bound with much higher probability, so this will be more salient. When the target is lower, we will be hitting the zero lower bound more often, and then all these effects will be more important. And we have a discussion in the paper over there. In particular, we argue that if you increase the target from 2 to 3%, most of these effects disappear. But if you lower the target from 2% to 1.7, you really, really make all these these effects much more salient. We also discuss how increases in wealth inequality that may come from an increase in idiosyncratic risk make also these shocks more important. And I think that's very interesting because it allows us to link changes in wealth inequality with monetary policy and, kind of help us to think about monetary policy from a new perspective. I'm running out of time, so let me wrap up and just highlight that once one starts to think about wealth inequality and monetary policy, there is really a lot of channels that one needs to consider, and that in particular, the channel that we have highlighted, we think there is the link between precautionary saving and the reduction in the real rate is a very interesting one. It's not all the story of what is happening in the economy. I want to emphasize that once more, but it's a very important one. And let me emphasize the novelty of the neural network algorithm that allow us to handle a very, very rich class of models that it was not able before. Let me stop over here.
Okay, thank you for your very informative presentation. Next, I would like to ask the Professor Taisuke Nakata from the University of Tokyo to discuss this paper. Professor Nakata, thank you very much for today's. Could you turn on your camera? Oh, yes, yeah, you're here. So please start the comment on this presentation.
Okay, can you see my slides?
Yes.
Okay, great. So thank you so much for the opportunity to present this important and interesting paper. So as we all know, the neutral real rate of interest has been declining in many economies. And with the current inflation target, the ELB, the effective lower bound constraint, has bounded frequently and is expected bind in future recessions. And at the same time, economic inequality has been increasing in many countries. And what this paper does is to investigate the interaction of these forces. So there are two key contributions in the paper. One is methodological. It provides a novel solution algorithm to solve heterogeneous agent New Keynesian model, Hank models with ELB and with aggregate uncertainty. The other contribution is substantive. In particular, this paper shows that the anticipation effects of ELB on inflation and the real rate are much larger in the Hank models than in the representative agent New Keynesian models, rank models. In other words, inequality amplifies anticipation effects of ELB. And why that's the case, well, the author shows with decomposition analysis that because ELB risk amplifies precautionary saving motive. So I'm gonna review some of the key mechanisms in the paper, and afterwards I'm gonna offer some comments. So in order to clearly understand the paper's contribution, it is useful to classify models with ELB into 4 categories, 2x2 metrics shown by here. So there are rank models with ELB, and there are Hank model with ELB. And there are models with aggregate shock, but without uncertainty, and there are models with aggregate shock with uncertainty. And in the context of ELB, aggregate shock without uncertainty means that when the policy rate is above the ELB, agents in the model do not take into account the possibility that the policy rate will go back to the ELB in the future. And in the context of ELB, aggregate shock with uncertainty means that the agents in the model, even when the policy rate is above the ELB, correctly takes into account the future possibility of going back to the ELB. Okay, so by comparing model without uncertainty and model with uncertainty, you can discuss anticipation effects. Okay, and so this anticipation effect. So by comparing rank with and without uncertainty, we have learned that even when the policy rate is above the ELB, anticipation of future ELB episodes by forward-looking household and firms puts downward pressures on the rate of inflation, which is called deflationary bias. and the real interest rate today under standard policy rule. So to illustrate this anticipation effects of ERB, it is useful to look at this picture that shows the steady state relationship between inflation, pi, and nominal interest rate, R. Okay? So the deterministic steady state of a model without uncertainty, without anticipation of ERB, is given by this point. That's the intersection of a standard Fiscal relation and the Taylor rule. Okay? With uncertainty, or in a model with anticipation effects, what happens is that the distribution of future marginal cost and future inflation becomes asymmetric in a way that pushes down the expected value of marginal cost and inflation in the future. And those expectations puts downward pressures on inflation today. Okay? And what it does is that it's going to push down these Fiscal relations down. Okay? So the stochastic steady state or risky steady state is given by the intersection of risk-adjusted Fiscal relation and the Taylor rule, which features lower inflation and lower nominal interest rate. And when the inflation coefficient on the Taylor equation is above 1, that means lower real rate. Okay. So this deflationary bias is not a mere theoretical curiosity. It has been shown that it can be large enough to explain the below target rate of inflation of 2010s in the US. And the idea of this deflationary bias surfaced occasionally in policy discussions leading up to and during the 2019-2020 Federal Reserve Strategic Review. And so what this paper does is to look at the interaction of this anticipation effects of ERB and inequality. And what this paper finds is that the inequality amplifies these anticipation effects on inflation and also on the real rate. Okay? And why that's the case? Well, there's a decomposition exercise that tells us why this is the case. And from the picture, from this table, what we can learn is that the inequality amplifies anticipation effects through amplifying precautionary saving motives against either aggregate shocks or idiosyncratic shocks. And for those of us who know heterogeneous macro models, not necessarily heterogeneous New Keynesian model, like Ayagari model or Haggett model of 1990s, we all know that the key determinant of the real rate in those models is the precautionary saving motives. Okay? And when we put anticipation effect of ELB, future ELB episode that is associated with low consumption and low inflation, that's gonna increase the precautionary saving motives. Okay, so that's what this paper does. Okay, so let me offer some comments. So I think it's a great paper. It provides significant contribution to the literature on both methodological and substantive dimensions. And anticipation effects of ELB and their novel link with inequality analyzed in this paper are of first order relevance to monetary policy, potentially having important implication for strategy. I will also point out that quantitatively, further exploration would be useful. Now let me give you some details. So I think the results are interesting because a priori, it's not that obvious how inequality affects anticipation effects of ELB. In Hank models, some proportion of households are borrowing constrained at any given point in time. And thus, a promised cut future interest rates are less effective in promoting economic activity today in Hank models than in rank models, as shown by Mackey, Nakamura, Steinson. So they respond less to future change in interest rate because they are borrowing constrained. Okay? And they also show that the Hank dynamics can be, in a reduced form way, approximated by rank model with a discounted Euler equation. So if today's economic conditions are less dependent on future economic conditions or the expectation of future economic conditions, you may think that the anticipation effects could be smaller in Hank models than in rank models, because anticipation by definition depends on expectations of future economic conditions. But what this paper shows is that that's not correct. And this paper shows that the reason for that is the amplified precautionary saving. So I think this result is not that obvious, and thus more interesting than otherwise. Comments on calibration. So I think the paper provides a very careful and thoughtful calibration, paying attention to micro facts as well as macro facts. I'm going to point out two important statistics of any ERB models when these models are used for quantitative investigation. So the first statistics is the model implied ERB frequency. So in the paper's baseline calibration, it's about 10% with the inflation target of 2%. In the US, since mid-1990s, when the long-run inflation expectation had come down and became stabilized, since then, ERB frequency is around 35%. And many research papers doing ERB models for policy analysis, my impression is that they tend to calibrate their models to aim for a higher ERB frequency than 10%. So that's something to keep it in our head. I will also point out that it is very hard to achieve a high ERB frequency when you take aggregate uncertainty into account without generating implausibly large deflationary bias. So what happens is that when you increase the size of the shock, or when you decrease inflation target, or well, if you do things to increase the ERB frequency, what's going to happen is that that's going to push this risk-adjusted Fisher relation even further down. And at some point, solution does not exist. Okay. All right. So another comment on, or another key statistics of ERB models is the expected ERB duration. So in this paper, it's less than 2 quarters. And in data, ERB episodes tend to be long-lasting. Again, there's a tension between increasing ERB frequency and therefore magnifying deflationary bias too much, which generates the risk of having a, ending up in a situation without any equilibrium. But this is something to keep it in our mind when we think about the quantitative relevance of any ERB models. 2 comments on monetary policy. Okay, so the paper currently assumes a truncated Taylor rule without inertia. But inertia in the policy rule is typically needed to capture Fed's policy rate decisions. And this is true even before ELB became an issue. But this is true especially at the ELB in order to capture forward guidance. And this is even more so after adaptation of flexible average inflation targeting that implies more pronounced lower for longer policies at the ELB. Okay. And another comment on monetary policy is, which could be outside the scope of this paper, is to think about strategies. So in rank literature, there are many solutions about how to overcome this deflationary bias. Okay. And it could be interesting to think about whether these strategies that work in rank models also work well in Hank models. I guess this is not that easy because doing normative analysis in Hank model is much more complicated than doing normative analysis in rank models, but that's something to think about. Okay, that's it. So I come back to my summary. I think it's a great paper analyzing first order issues to monetary policy that could have a potentially important implication for strategy. And I also think that quantitatively further exploration would be useful. Thank you.
Thank you. Thank you so much, Professor Nakata. Professor Fernández-Villaverde, could you reply for the Professor Nakata's comment?
Okay,
Please.
thank you. So first of all, let me thank you, Professor Nakata, for his very nice comments, as it was an excellent discussion. And yes, I fully agree that the paper requires a little bit more quantitative effort. The part of the reason we have not really fully explored all of these issues is very pragmatic. Is we wanted to present the paper in a few conferences and get a sense of what type of exercises the profession will be more interested in. The problem with this type of rich models is that one can do 24 different things. It's a good idea to get a sense of what people look for. So I think that, for instance, your point about exploring the persistence of monetary policy and thinking about possible strategies are very well taken. Yes, they can be implemented. The neural network approach, one advantage it has is that it scales up very well. So we can definitely try to explore those too. So those are very well taken points. The only place, and I think you agree with me on that, where things get a little bit trickier is how to increase the percentage of times you're at the zero lower bound, because we know that even in a rank model that becomes very hard. I had this paper in 2015, Nonlinear Adventures at the zero lower bound. And what we do over there is we introduce a wedge, an exogenously given wedge on the Euler equation. So maybe we could do something like that over here. But I think that as a profession, we still have not been able to wrap our head around about existence of equilibrium in models with the zero lower bound binds with a very, very high probability. So that's a tricky issue. But the question I like the most is exactly what you're saying. How can one use this Hank model for a strategy and to think about it? And that was part of the motivation we started working on this, was precisely to think about optimal strategies of the central bank. So we need to work more on that. That's it.
Thank you so much. So let's move on to the question for the floor. I really appreciate your question. So please kindly allow me pick up a few of your question. Okay, so now the first question comes. Professor Shioji, could you turn on your camera and microphone?
Okay. Can you hear me?
Yes, yes, please.
Okay. Okay. For some reason, yeah, I turn on the camera, but I don't appear. But anyway, yeah. Okay. As long as you can hear me. Yeah, I don't know what's going on, but anyway, yeah. Thank you for a very exciting presentation, and I kept wondering how we could adapt to your model to understand what's going on in the Japanese economy. And I have two questions about how we could modify this model to fit the Japanese reality. First question is, in your model, everybody works.
Mm-hmm.
In Japan, we have lots of retirees, and the share the proportion is increasing. Mm-hmm. And they don't earn wages, but they earn the interest, and they have lots of assets. And so I'm wondering if you introduce like this age structure, or maybe just people who don't work, how the result might change because of that. So that's question number one. Question number two is, I understand that in your model you only have real assets.
Yes.
But I think in in reality, Japanese old people, there are two types of old people in Japan. Some people are rich enough to hold on to like real estate, stocks, mutual funds, but most elderly are poor and just have some, liquid deposits whose values are fixed in nominal terms. So if you
Yes.
introduce those distinctions, how would you expect the models to the model behavior to change? Thank you.
Okay,
And I apologize for the video.
Okay, thank you. Those are two great questions. So let me start with the second one. I may have not explained this carefully when enough. I apologize when I was presenting. Assets in the model are nominal, so they agents accumulate assets in nominal government debt. That's why in the budget constraint I had the rate of return, the nominal rate of return divided by inflation. So in that sense, I think we capture well the fact that a lot of people are saving in nominal assets. Now we could have a richer version of the model where we will also have real estate or physical capital. After playing for many years with this type of models with wealth heterogeneity, I don't think that will matter that much. Some of the quantities may change a little bit, but I think that the main message of the model will be the same. So that I'm not that concerned. Your first point, though, is absolutely right, which is the model doesn't incorporate any type of overlapping generation structure. And that's something that I have been very interested in thinking about how you can take these overlapping generation structures to this hunk class of models. So a relatively straightforward exercise, which will be a very nice extension of the model, will be to go and instead of having just one household, or sorry, one type of households, one could imagine having households that age stochastically, like in a Blanchard type of model. So with some probability, so you have two shocks. One shock is the idiosyncratic labor shock, and the other shock is a shock of aging. Suddenly you age, and that basically means that you don't make any income any longer. And I guess that with some probability you will become young again, but the way to think about that is really that you are being substituted by the next generation. That's what I have done in a paper. I mentioned it before, a recent paper with Robert Barrow in Economic Journal. So you could do that relatively easily in this model, and then you could calibrate the probabilities of aging to the Japanese economy demographics, and that will be a very interesting exercise. So that's the way I will do it. What numbers I will get out of that, I don't know from the top of my head. If I were going to guess, I think that what you're saying is exactly right. That because who are working and who hold all the assets are very different people, the distributional effects of monetary policy at the zero lower bound will be even more separate and more different than in the current model, and that's going to get a lot of interesting action. But that's the way I will try to do it. Just introduce an aging shock and calibrate that aging shock to the demographics of Japan.
Okay, thank you very much.
Thank you for Professor Shioji. And the second question comes from the Professor Alexander Ludwig. Ludwig, please.
Jesus, thank you very much for the interesting paper. I have one bit of a technical comment on the Benner-Buch tax function. Because with that function, we know at the lower end of the income distribution, it gives too large transfers. So if you augment it with a transfer payment, then maybe this risk will hurt the poor households even more.
Yes.
And that might be one. And the other one is a technical comment I have on the comparison between the neural networks and the Crusoe-Smith. I mean, we know this comparison is a bit unfair towards Crusoe-Smith if you compare it to the naive one. Because you could say, let me compare it to a Crusoe-Smith model, given that I have all these large shocks. Let me add as a moment in the Crusoe-Smith the fraction of households at the borrowing constraint. And I mean, I still see the advantage of the neural networks, of course, but that might be a little bit of a fairer comparison, I think.
Okay, Okay, so two things with respect to the first one. Yes, you are absolutely right. And Joel Marbet, my co-author, has been playing with that. And if he was here, he could maybe give you a little bit more details. And yes, that's one of the things we need to work a little bit. Also, remember, this is a model where being poor is not that bad because you still get a little bit of income from the firms, from the profits of the firms. But really poor people do not really get any income from the firm. So when you are poor, you are really poor. So that will make playing with the tax function and playing with the way profits are distributed may make some of these effects even more salient and make things much acuter. So in that sense, I think we are again trying to kind of give a cautious scenario. My suspicion is that anything that I do to the model will make these numbers greater, not smaller. With respect to the Crusella-Smith, yes, fully agree with you. We in the original paper, in the paper with Samuel and Gallo, we always write down naive Crusella-Smith, and maybe I should have said that over here. And the reason we say naive Crusella-Smith is because we want to highlight that this will be kind of the default Crusella-Smith from the textbook. And of course, we try to argue, look, a much smarter Crusella-Smith can do a little bit better. But my answer to that is always, you can always think about Crusella-Smith as a trivial neural network with a linear activation function. So what you are telling me is that, oh, I can do a little bit of a more sophisticated activation function and do it a little bit better. Then my counter argument is, well, just throw this to a dense neural network, and then the dense neural network does it for you. So why do you want to spend a lot of time tinkering with it? So we only wanted, and I guess you are right, we should say naive Crusella-Smith. We only wanted to highlight that the extra flexibility given you by the neural network allows you to do this. And I don't want to take much more time, but let me put it in this way. The great thing about neural networks is that they require less domain knowledge, less domain expertise. By that, I mean you don't need to know ex ante a lot of the properties of the model to design a good neural network, while the more sophisticated Crusella-Smith requires that domain knowledge, which you may have, but maybe the person to the left in the next office does not have. And that's one of the things we like about this. So that's how I will justify it. But that's a great question.
Thanks.
Thank you for Professor Ludwig. The last question from Professor Ippei Fujiwara. So please.
Okay, can you hear me?
Yes, please.
Okay, thank you very much for the fantastic presentation. I have a small question. First small question is still, can you consider the deflationary steady state in your framework? And the second question is related to the deflationary steady state. So as you know, in Japan, we have been in a zero lower bound for 25 years, and still the 10 years bond yield is close to zero. Then some people are saying that people's expectation about the trend inflation is close to zero. Or some people are saying we are caught at the deflationary steady state. But according to the Taisuke's beautiful figure about the Fisher equation, considering the future zero lower bound into account, then Fisher equations going down and down. So eventually and also in your idiosyncratic framework, it further goes down to I think it further goes down. So that eventually, maybe the one lesson I got about the Japanese situation is that it doesn't make that much sense to distinguish the deflationary steady state or inflation expectation is low. There's not that much difference anymore. So these are my questions or comments.
Yeah, thank you. Those are great comments. So yes, basically I agree with you on that. The model at its core has, even if we have non-neutrality in the long run, it still has a little bit of a Fisherian aspect to it, which is the real rate in the long run really depends on the expectation of people about inflation in the long run. So if we are stuck in that deflationary steady state, then we are centrally have all these type of situations. Coming back to the discussion where we were talking about the possible strategies, what the model suggests is that precisely to avoid that type of deflationary steady state, increasing the target a little bit may go a long way. And the thing that I find interesting is that we don't require a very, very large increase in the target. We are not talking here about going from a target of 2% to 5%. We are talking about going from a target from 2 to 3%. And that, in the context of our model, is enough to kick the economy out of that deflationary spiral. So I think that the model will suggest that modest change in the strategy of the central bank may have relatively large payoffs.
Okay, thank you very much.
So thank you for all the presenter and the commentator. I'm a central banker. From the viewpoint of the central banking, just a simple comment. It is very informative for the central bank communication, because the textbooks say that the pure dichotomy between the monetary policy and the fiscal policy. But the outcome of this paper require the much burden in the fiscal policy due to the zero lower bound. And the second one is a positive news for the central bank, because the 2% target, it doesn't matter to escape from the zero lower bound. Thank you so much. So it's the end of the first session. Thank you for all.